Okay, now it's time for us to talk about the operations with fractions. So we need to review multiplying, which is usually what we always go over first. Here we have our rules that I copied and pasted in here. The rule says if you've got two fractions, a over b and c over d, if you were to multiply those, our answer is a times c over b times d. Now, do you see what they're doing here? They're just simply multiplying across numerators and then across denominators. Now remember though, we always write our fractions in lowest terms for our answer. So we can either use this rule specifically, and then once we have our answer we can reduce down. Or, if you'll remember, there was a little bit of a trick that you could use before you multiply that would help you not to have so much to have to reduce down later. So, for instance, here we have this problem that says multiply 7/9 times 12 over 14. Now, we could do this by using pure directions, or pure definitions, rather, I should say. We could multiply 7 times 12, and then in the denominator we could multiply 9 times 14. Now this is going to give us some pretty big numbers, and then we're going to have to reduce that down at the end. Instead of doing that though, can we see that there are some common factors in numerators and denominators here? Absolutely. Look at the 7 and the 14. These both have a 7 in common. 7 will go into itself one time, and 7 goes into 14 two times. Now, we can continue reducing or canceling as long as we look at numerators and denominators. You have to have one of each. You cannot cancel on the top and on the bottom. It has to be one of each. So looking at this 9 and this 12, I see that they have something in common also. They have a 3 in common. 3 will go into 9 three times. Oops, that's not a very good 3 though there. And 3 will go into 12 four times. Now, we might still be able to do some more. Looking here, we still have numerators and denominators. And look at this 4 and this 2. We have a numerator and a denominator that have something in common that we could cancel out further. 2 will go into 2 one time, and 2 will go into 4 two times. Now, looking at what we have left on the numerator and the denominator, there's nothing else that we can do to cancel tops and bottoms. So now we would go through and multiply what's left. 1 times 2 would be 2 on the top, or in the numerator. On the bottom, 3 times 1 would be 3. So our answer here now would be 2/3. Now, when it comes to mixed numbers, we can really do the same thing, except we really need to have them we can't really look at them as mixed numbers, so they need to be regular fractions. Now, if you'll remember how to change these, to change from a mixed number to a regular improper fraction, we multiply up and then add. So this would be 3 times 3 is 9, plus 1 is 10, and then we always write it over that same denominator. Times. We do the same thing. Multiply. 4 times 1 is 4, and then add. Plus 3 would be 7. So 7 over, keep the denominator of 4. And now we can do the same thing. Here we can cancel between the 10 and the 4. 2 goes into 4 two times, and 2 goes into 10 five times. Now nothing else will cancel. So we have 5 times 7 is 35, over 3 times 2 would be 6. Now this is a fine answer, but it's an improper fraction. And since they gave us mixed numbers to begin with, we probably have to write our answer as a mixed number. And if you'll remember how to do that, this fraction 35 over 6 is just a division problem, so we just divide. 6 goes into 35 5 times, so that would be 30 with 5 left over. It would be 5 and 5, 6.